in section 5, we're running some code here that's going to work with what we call a nested if. That just means that you put an if statement inside of another if statement. And then for that second if statement to run, then both if statements would have to be true. So here I've got a number z, okay? If z's less than 10, we'll print that the number is less than 10. And then I've got a second if statement that says that, if the number is even, right? So it has a modulus of 2 that's 0, we print that the number is even. So when I run it, we should see both of those things print because we pass both of those tests. Now, however, if I were to change this number to say 18, okay, the number 18 is even, but we won't print that the number is even because we're never even going to get a chance to ask this question. That's the idea of a nested if. So you can only reach that condition if you've passed the first condition. So we're actually going to see both of those displays disappear. So the number 18 is an even number, but it doesn't display here that it's an even number because the number wasn't less than 10. And so since the way I had this structured was my one if was inside of the other one, okay, I didn't reach that second one. So that's the idea of what we call a nested if, just putting one if inside of another. You got to pass both tests, in other words, to reach the second print there. Okay, if we look at a next piece here, we talk about some more logical operators. So we learned about some relational operators last week, like equals equals, less than or equals. And now we have what we call logical operators. Okay, these also result in Boolean values. And there's the not operator. Sometimes it's called like the negate operator. That's going to reverse any Boolean. So if the Boolean was true, now it would be false, vice versa. This is our and. Okay, the and operator is going to evaluate to true only if both sides of it are true. And then the or operator is going to evaluate to false only if both sides of it are false. Okay, so here I've got some examples of some and operators. So again, the and operator is a Boolean operator. It's going to result in a Boolean value. Okay, it's only going to result to true if the left condition is true and the right condition is true. And so if you look at my 3 here, A is 10, B is 9. Those are both less than 12. So that would result to true. However, C is not less than 12. So that would not result to true. And if I gave it 2 falses, that's still a false. It's only true if both sides are true. Okay, and we see that right here in the output. In the or operator, it's only going to be false if both sides are false. Under any other set of circumstances, it will be true. Okay, so right here, A is not at least 12 and neither is B. Those are both false conditions. This would end up displaying false. Okay, here, A is less than 12, C isn't, but it doesn't matter. It only takes 1. Okay, here I just gave it 2 straight Boolean literals and they're both true, so this would still come out to true. And I wrote false here. I think I said true and wrote false. Okay. So a logical or operator will only result in false if both conditions of it are false. All right. We see that right here. And again, notice that these are resulting in a single Boolean value. Okay. The order of the operations here obviously matters. Okay. So in the order of operations, these logical operators have lower precedence than your relational operators. So you're being forced to figure out this first, okay, which was true. And then you're being forced to come over here and figure out this one, which was true. And then it's putting those two together, true and true, all right? So the relational operators we learned about previously have higher precedence than these logical operators. And that's true for the and for the or. And then I think I need to change my note here. The not operator, which I'll change this on yours. Okay, so the not operator, or sometimes it's called the negate operator, is only going to give you the opposite every time. Okay, so it evaluates to false only if true, originally true, and it becomes false then in the opposite of that. right? So it's just going to reverse whatever it originally saw. And so like right here, A equals 12, okay? That was a false condition. A was 10. So the A equals 12 in a sense was false, but then the not operator is actually going to flip that and make it true. So not false becomes true. Here, okay, is C an even number? No, C is 15. So C is not an even number. That's a false statement. However, the negate operator, again, is going to reverse that to true. And if I took a true operator here, okay, and I said, not true, that would be false. And not true would be false again. And that's how I got this one to say false. Okay, and we see those here with our not operators. Now, the not operator has higher precedence than the relational, the relational operator equals. So if I did this, I'd actually get an error message. You're not allowed to let the not operator ever touch a number. It can only touch a Boolean condition. So you can negate a Boolean. You cannot negate any other type of primitive. So like this wouldn't make -10 or something. So it has to be only influencing a Boolean. So the parentheses here required the Boolean to be determined first, and then the negate operator reversed it. So you got to be a little bit careful in your structure there. And if we have like multiple logical operators, then it's still just going to break itself all the way down to like a single Boolean condition. And the precedence here is really important. I made a little table for you, and you can find other tables online. I went ahead and made one for you just because a lot of the stuff in the AP subset doesn't get emphasized for us. So like I took some things out here. Like if I took a table from online that had like 15 rows in it, and I took a few out. So for us, this is like what we need to know. The highest precedence, parentheses. We haven't learned about array subscripts yet, but we will. And then the member selection, that's our dot operator. So like when we're calling methods. Increments and decrements. But then notice that the logical negation operator has very high precedence. Okay, so that's that exclamation point. That's what I was saying a minute ago. So you got to be kind of careful with how you use that. You can't let it try to negate a number. It can only negate Booleans. Then you got all your arithmetic. Then you've got your relational operators. And then way down here, we have the logical and or. So notice that they come below all of the math, all of the relational operators. So they kind of wait around to the end. Also notice that the and or operators don't tie. So they each get their own row, and the and operator has higher precedence than the or operator. Okay, so the and operator actually comes first over the or operator, and then you have all of your assignment operators. Okay, now that's going to be really important as we try some of these down here. So according to that, like if I have mixed ands and ors, I have to actually evaluate the ands first. So in a sense, it's almost like there's a set of parentheses around these two and operators. Even though I didn't put them there, the way Java is going to look at this is it's going to evaluate both the left and the right of that or first. So it would look over here. Remember, an and operator has to see two trues to be true, otherwise it's false. So that would evaluate to false. Same thing right here, that would evaluate to false, and then ultimately false or false would evaluate to false. And so ultimately we would see false appear from our first, or actually our second multiple logical operator. And that would have been like this one right here. No, sorry, this one right here, okay? And then if you look at some of these other ones here, this one's a little different. I put the and in the middle. So this one would actually come to the middle first, and it would say false. Now, both of those or operators would tie, so you would go left to right. You would look at false or false, so that would be false. But then finally, you would have false or true, and that would evaluate to true. And that's the true that we're seeing right here, okay? So you got to watch your order as you step through these. This is a classic AP kind of trick question here, and I'll show you like another variation of it. But if you read this strictly from left to right, you would get false, okay? but this actually evaluates to true. If you read it from left to right, and you did the OR operator first, you would say true, and then true and false, you'd say false. However, that's not what Java does. Java gives higher precedence to the AND operator. So it looks at the AND operator, sees false and false, it goes false, and then it evaluates the OR. Now remember, in an OR operator, unless there's two falses, you're going to get true. So this one does evaluate to true, and that's what we're seeing displayed over there to the right. Okay, so the order of operations really does matter when we look at these logical operators. And then finally, there's something called a short circuit. Now this is weird. So in a short circuit, says when the result can be determined from the first value, okay, and you're doing these ands and ors, all right, and if you can determine from the first value what the outcome is, Java doesn't even bother to read the code in the second one. Oh, what is that? That's what they mean by a short circuit. Like it quits a little bit early. It stops short of what it needed to do in completion. So why would we ever do this? Well, in an OR statement, remember, the only way for an OR statement to be false is if both sides are false. Therefore, if you think about it logically, if the first side is true, well, then you can't have both sides be false if you know that the first side's true. And so if the first side's true, Java doesn't bother reading the second side. Now, why does that matter here? Well, I put in kind of a weird second side. Dot equals is a Boolean method that we learned about, okay? But here's the catch. I did an out of bounds substring. This should have thrown an out of bounds exception, okay? And it didn't throw an out of bounds exception because Java never even bothered to read this little piece of code that I put here because it already knew the outcome was going to be true. Now, watch what happens if I turn this line on. In this line, I put a false on the left of the OR. That means we don't know the outcome yet, right? If you have two falses, an OR can be false. If you told me the first half is false, I'd say, well, what about the second half, right? If you told me the first side was true, I wouldn't care about the second half, and neither did Java. But now I'd say, well, what about the second half? Well, the dot equals method could be true or false. We got to go figure it out. And in the process of figuring it out, it's now going to go out of bounds. This is not a compile time error. It's going to let my code run. Look at all the output it gave me. It ran my program. Then it crashed midway as it went out of bounds in that substring that I created on purpose to go out of bounds, okay? And it crashed. Now, why didn't it crash here? I did the same substring. That should have gone out of bounds too. The short circuit actually prevented that piece from running. We already knew the outcome, so we didn't even bother with the other half. In an AND operator, it's the opposite. Remember, an AND operator has to see both sides true to make true. So if you knew the first side was false, who cares what the second side is? It can't undo that false, so nothing's going to matter. So it doesn't even bother running this bit of equals code here. And even though that would have gone out of bounds in the process, it never ran it anyway. So it didn't end up going out of bounds. Okay, here, if I change it here, if you tell me the first side of an AND is true, I say, well, what about the other side? Okay, now the other side is important. Therefore, it's going to try to run this piece of code, and it's going to go out of bounds now and crash. So sometimes we use short circuits to avoid going out of bounds. And we'll see this a lot more when we start doing like array syntax in the future. Okay, so this will be like a bigger deal to us when we get into like unit 6 and unit 7 with array and array list. Now, here's another example of the impact of a short circuit. You might remember us learning previously in unit 1 about the increment operator. The increment operator, okay, makes a variable increase by 1, and it actually causes that reassignment to happen right at that moment. So it makes x go from 10 to 11, and it actually reassigns x to 11, even though we don't see an equal sign there. So it seems like if I ran this piece of code and then later I printed x, I should get 11. Now, the first time that I do it, I actually get back the number 10. So in other words, the increment never took place and it never actually added 1 to x. Well, why not? I mean, it said x plus plus. Why didn't it increment the variable? Okay, well, because it's short-circuited. Since it saw 10 equals 10 true, and it was an or statement, remember in an or statement, right? You have to have both sides false to get false. So if you know one side's true, who cares what the other side is? So once it saw true, it just quit. It shut down and it didn't execute any of this code to the right of the or. That was the short circuit. Okay. In my second example, I said if x is not 10, that's false. X is 10. And in an or statement, if you have two falses, it's false. So if you know the first side's false, then you go, well, what about the other side? And so now you have to continue running the code. You don't short circuit. And look at what happened. This time we actually got 11. So there was 2 increments here. Okay, there was 2 x plus pluses, but only one of them actually took place. It was the one that didn't short circuit.